Alright, as always, this is Miss Jacoy. So first, do try the problem. Read it, write out your variables, draw a picture, try to figure out what equation it is, and solve it. Go ahead and do that now. Pause the tape. Video, I'm old. Alright, so first read it. How fast, that's kind of something what we're talking about, would you have to throw a rock straight down in order for it to fall 40 meters in 3 seconds? Okay, so let's draw a picture of this. So I'm assuming 40 meters is a pretty good distance, so you're on some sort of cliff. You're throwing a rock straight, that was not terribly straight down. That distance it's going to take is 40, I'm going to write this smaller so I have room, 40 meters. And you said it's going to do that in 3 seconds. That's your goal. Alright, so we started to, but let's write out some things we know. We know that your final position is going to be 40 meters. Or, let's think of this another way. Did you start at 40 meters or did you end at 40 meters? I like to say I started at 40 meters and then it hit the ground, which is at 0 meters because it's the ground. The ground hasn't gone anywhere. But again, you can pick different things. It's alright. The difference between them will have to be 40 though. From here, it's talking about how fast, so I'd want to know how fast did I have to throw it. If we're talking about me throwing it, is that the velocity it had in the beginning? Or is that the velocity it had at the end? So you were throwing it, you were up here, is that the beginning or the end? Hopefully you can tell yourself, that's at the beginning. So we are looking for initial velocity. It has to do this feat in 3 seconds. There's one more thing we know, because even though you are throwing it down, it is in the air by itself, being affected by gravity. So your acceleration is still that negative 10 meters per second. So because it started at 40 and went to 0, I'm good with calling this down. It's consistent. Note, if you're throwing it down, this number is going to be a negative at the end. If you don't have a negative, it's cool. You might need to try something different. Alright, so let's now look at what formulas we could use for this. Hopefully, it becomes obvious to you which one we should use. Alright, the only one that contains all of these variables is our first one, x equals x naught plus v naught times t plus 1/2 a t squared. Alright, so we can start plugging in equations. Plugging in numbers. So, our final is 0. Our initial is 40 meters. Plus, we're not sure the velocity, but it is going to take it 3 seconds. Plus 1/2 negative 10 meters squared times t squared. 3 squared. Alright, so this whole term you can just solve for. So you get 1/2 times negative 10. It's going to give you a negative 5 meters per second squared. This is going to be times 9 seconds squared. 3 times 3 gives you 9, so 3 squared is 9. And then your units also square. Multiply those, you get a negative 45. Your seconds cross out, so it's in meters. Alright, we go back up. This term we can't really do anything with. We're kind of stuck leaving it as v naught times 3 seconds plus 40 meters. So notice, look, these now have the same last name. This is in meters, this is in meters. So you can go ahead and add them, or subtract them if you will. So it'll be negative 5 meters plus 40 minus 45 gives you a negative 5 plus v naught times 3 seconds is still equal to our 0, so we're going to want to move this to the other side. It's negative, so you're going to add it. So you're going to get a positive 5 meters because you added this 5 on both sides. And it's going to equal V naught times 3 seconds. Now you must divide by 3 seconds to get, so plugging 5 divided by 3 in, it's going to give you 1.67. You got to round it. Meters over seconds, so you're going to have meters over seconds equals V naught. Alright, hopefully this helped you understand this a bit, and I will see you all tomorrow.